All right, so now let's get into more details about the different types of radiation that's commonly released. And let's start with alpha particles. So an alpha particle contains 2 protons and 2 neutrons. So when an alpha particle is released by a radioisotope, that nucleus releases 2 protons and 2 neutrons. Now, in terms of writing the atomic symbol for an alpha particle, since it has 2 protons, we can use the chemical symbol for helium for an alpha particle, because essentially the only element in the periodic table with an atomic number of 2 is helium. But keep in mind that an alpha particle is not the same as a helium atom. Why? Because a helium atom not only has 2 protons, but it also has 2 electrons. So the charge of a helium atom is 0. On the other hand, and a helium atom would also have 2 neutrons as well. Don't want to forget about that. An alpha particle has 2 protons, 2 neutrons, but it has no electrons. Unstable nucleus releases 2 protons and 2 neutrons in this alpha particle. There's no electrons present. So for an alpha particle, the charge is +2. So we use the chemical symbol of He for an alpha particle because it has, in theory, it has an atomic number of 2. And it would also, we didn't really talk about this yet, if we have 2 protons and we have 2 neutrons, the mass number is 4. So you can see in the upper left of the atomic symbol, the mass number is 4. So I also want to mention where that came from. But again, wouldn't be the same as an helium atom, because if we used the periodic table to write the atomic symbol for a helium atom, we would write 4,2He. But in that case, the charge would be 0. For an alpha particle, the charge is +2. 2 protons, 2 neutrons, no electrons associated with it. Just to also mention, sometimes the alpha particle, in terms of atomic symbol, is also written as 4,2 alpha. So instead of writing helium, sometimes the Greek letter A is used. And that's perfectly okay as well for the atomic symbol of an alpha particle. Okay. Second, we have beta particles. So your beta particles are high energy electrons. Now, essentially, the different forms of radiation are released when there is a change in essentially what's going on inside the nucleus. And the nucleus essentially involves your protons and your neutrons. Well, if we're sort of looking at changes that occur inside the nucleus with protons and neutrons, how is an electron released? Or what does an electron have to do with it? Well, essentially what happens here is that a neutron is changed into a proton. That's the change going on inside the nucleus when a beta particle is released, that a neutron is changed into a proton. When that occurs, what's released from the nucleus is an electron. And the atomic symbol for an electron is 0 - 1e. E representing electron, or as you can see towards the bottom here, 0 - 1 beta would be acceptable as well. -1 atomic number, because essentially if you think about it, electrons and protons are sort of opposites of each other. Well, they have very similar characteristics, except their charge is opposite. Protons have a +1 charge, electrons have a -1 charge. So in theory, an electron would have an atomic number of -1. If a proton has an atomic number of 1, your electron would have an atomic number of -1. Mass number of 0. Why mass number of 0? Because an electron contains no neutrons and no protons. It's an electron. It's not a trick question. An electron has no protons and no neutrons. So atomic number of -1, mass number of 0, chemical symbol of beta, or E for electron. And they are released from a nucleus when neutrons are actually changed into protons. The protons stay within the nucleus. The beta particles are released. Now, one other thing to mention on this slide. This 11H atomic symbol on the bottom, this essentially is the atomic symbol for a proton. Now, how do we come up with that? Well, in theory, a proton would have an atomic number of 1. Again, what's the only element in the periodic table with an atomic number of 1? Hydrogen. So that's where the H comes from. A proton has 1 proton and no neutrons. So that would give it a mass number of what? 1 plus 0 is 1. So that's where the 11H comes from. But keep in mind that a hydrogen atom and a proton are not the same, because your hydrogen atom is neutral. Because not only does a hydrogen atom have 1 proton, it also has 1 what? It also has 1 electron. But a proton has a +1 charge. And that stems from the fact that a proton has 1 proton, but no electrons. I'm trying to make that look a little bit clearer, like a +1. So it has a +1 charge associated with it, because there's 1 proton and there's no electrons. While I see it here, one other thing to mention, the 10N is the atomic symbol for a neutron. A neutron has no protons, so in theory, the atomic number would be 0. It would have no protons and 1 neutron, so 0 plus 1 is 1. So the mass number would be 1, and then we use a small symbol of N, small n, to represent neutron. And then also for the proton, one other thing to mention, sometimes 11P, small p, is used for the atomic symbol of a proton. I like the H a little bit better, but you might also come across 11P. That's also an acceptable atomic symbol for a proton, but it's got to be a small p, because if it was capitalized, then everybody's going to think phosphorus, and that's not what we're thinking. All right. Positrons. So positrons are essentially positive electrons when a proton is transformed to a neutron and a positron. So again, what is the change in the nucleus amongst the protons and neutrons that causes positrons to be emitted? Here, your protons are changing into neutrons. And when that occurs, you also get a positron as well. The new neutron stays in the nucleus, and the positron is released from the nucleus of the atom. The atomic symbol, given in the upper corner here, opposite of an electron in terms of charge. So where an electron has a -1 charge, a positron has a +1 charge. Now I wouldn't consider, now again, it's a little bit tricky here because it doesn't have a proton. It's a positron. It's a positive electron. So usually when we see an atomic number of 1, we think 1 proton. That's not the case here, and that's really why they put the sign in. That this sort of just reflects the opposite charge that a positron has as compared to an electron. And because there are no protons and no neutrons, the mass number would be 0. And then again, we use the small e. Or we could also use 0 plus 1 beta. Because again, your beta particles are high energy electrons, your positrons are positive electrons. So essentially they are beta particles that have a positive charge. So that would be an acceptable atomic symbol also. And then finally, your gamma rays. Your gamma rays are the high energy radiation released from a nucleus when it decays. They have no mass or charge. And I'm not so concerned about the equation that's on the bottom here, because I really don't want to even try to really interpret that with you. One of the ways I sort of like to think about your gamma rays is that essentially it's a messy room that gets cleaned up. But what's in the room is not destroyed, or is not kicked out of the room, so to speak. It's a messy room that's gotten cleaned up, but everything that was in that room stays in that room. Because there's no protons or neutrons associated with the release of gamma rays. That's pure energy. A gamma ray, in terms of an atomic symbol, and you see it again in the bottom corner here, has no atomic number and no mass number. So a lot of times, instead of writing 0, 0 gamma, we would just write gamma for the gamma ray. Right? No protons, no neutrons associated with it, because none of those protons and neutrons are not a part of gamma rays when they're released. You know, there's been a rearrangement of how the protons and the neutrons are laid out in the nucleus to make it more stable, but the actual number of protons and neutrons doesn't change. Okay, so the actual well, sometimes it takes more work just to get the pen. The actual number of protons and neutrons does not change. Whereas for the other types of radiation, the actual number of protons and neutrons in the nucleus of that atom changes. Okay, so that's again the key difference. All right. And then on the last slide here, just have all about the different forms of radiation in terms of their symbols. We talked about protons and neutrons as well. What change in the nucleus occurs? You know, 2 alpha particle, 2 protons and 2 neutrons are emitted. Beta particle, a neutron changes to a proton and an electron is emitted. Positron, a proton changes to a neutron and a positron is emitted. Gamma rays, energy is lost to stabilize the nucleus. And then I guess, you know, protons and neutrons themselves can be emitted. We're not so concerned essentially about that right now, but they would be included in the different forms of radiation as well.